Okay, hi there. So in this screencast, I'm going to show you how to use Logger Pro to put some data into Logger Pro and then use the graphical analysis features of Logger Pro. So first thing when you start Logger Pro, you should just get a blank little spreadsheet, some cells over here, and a blank graph. And you have to put your data in. So I'm going to do that, and so it'll magically appear. And so I'll edit out the part where I'm actually inputting the data. So there's our data, and this is Dimitri's data, I believe, for the pendulum lab, trying to find a value for the gravitational constant. We put in I put in the numbers here, but Logger Pro still has a scale of 0 to 100. That's the default in each direction. So I'm going to click on this auto scale, and when I do that, it will pick the best scales for the x and y axes to display it, and it's connected to points. It's had little points here and there, and it's connected them. But we don't want to do that. So I'm going to right-click on the graph and uncheck this box that says Connect Points. And if you want to put the point protectors on, it puts a circle around the actual point, and you can see it a little bit easier. So the title, yeah, we can give it a title. What is it? So this is pendulum. Period versus length. Okay, so there it is. And if you don't like the way these points are squished in here, you can come down here and drag the axes back a little bit in each direction. And same with the vertical. Bring this down a little bit. You can just, if you click up here when the cursor changes, you can type in whatever value you want. So 1.1, for example. That'll make the top value 1.1. Okay, so we need to give this data set a more meaningful title. So the X column here is the actual length. So if I click on that and then right-click on it, right-click on it and give me the column options for the data set X. And let's give it a name. This is length. And a short name, how about L? And the units are meters. And the options here, let's see, error bars. We're not going to have error bars in the length direction because we were able to measure the length to within a millimeter or so. So that's going to be insignificant. So all you need to do is say that the error in the length measurements is insignificant. Or say what it is and then say it's insignificant. So we're done there. Over here on the Y, we'll right-click on that, column options Y, and column definition tab. This is the period, and short name is T, big T, and unit is seconds. And we'll put in we're going to need error bars for this. We'll put this in later when we talk about that. So we'll be done with this for now. So now we have actually some length versus period here. Well, we need to, we want to see period squared. So we need to add a new calculated column for period squared. So we're going to come over here on the data menu and go to new calculated column and call this period, and we can come over here and give it a superscript of 2, period squared. Short name would be T squared, and units are seconds squared. There we go. And we'll add, oops, it wants an expression. Don't want to forget that. So we have to tell it what to calculate. So in this case, we're going to come over here where it says variables. We want our period, and it appears in quotes, and we're going to multiply that. So that's the asterisk, and multiply that by itself. So period. You could also use the caret or the up arrow over the 6 and squared. And there's probably even a square function. You could come in here and do where's the math? Where's some math functions? There's square root. Maybe no square. Okay, so be it. So period times period gives us period squared. And there that is. And our graph is over here. We need to drag this so I can see. There we go. So if I bring my cursor over here onto the y-axis label, I can choose what data I want to display, and I want period squared. So length by period squared. And then I'm going to have to auto scale again. And there we go. And I can drag this back. Make this look a little better so I can see the endpoints. There we go. And now it looks nicely linear, whereas before the period indeed looked kind of square rootish. Okay, so there we have our plot, and if you want, you can get the a linear fit right now. And I can't read that. I'm going to pause it. Okay, so what we want to do is click on the column here for period squared and go over here and choose a linear fit. And we'll get a linear fit here for our data. This is the best fit line. You can see this bracket over here. You can click and drag this put the cursor over it when it changes, and you can select what data you want. It automatically assumes all the data there. So I can't read that, it's too small. It looks like the slope is 3.8 something maybe. So this will be our best fit line. So we can do that anytime. What we want to do is generate some error bars now. So we talked about having a timing error of plus or minus 1/10 of a second, both when we start and stop the stopwatch. So that would be 2/10 of a second on our timing for each trial. And the instrumentation has an accuracy of 100ths of a second, or 10 milliseconds. So we take plus or minus half of that, and that gives us plus or minus 0.005, which is really insignificant compared to the human reaction time uncertainty of 0.2 seconds. So the total would be 0.205, plus or minus 0.205 seconds. Now in this particular experiment, they did 10 oscillations back and forth. So the error on any one period measurement would be 1/10 of that, or plus or minus 0.02 seconds. So that's what we're going to use for the error bars here. So I'm going to come over to the period squared and right click on it, column options, period squared. Under the options we have the error bars, and so we want 0.02 seconds, and that is for the period. So for the period squared we have to double that, so it'd be plus or minus 0.04 seconds for the period squared. Now we can add that as a fixed value or a percentage, and we're going to, so if I just do 0.04, we'll do just a fixed value for this one, and you'll see the error bars appear. So now we have to find the maximum and minimum slope. So we need to come to the data and add a new manual column. I'm going to call this how about minimum slope, and we'll call that min, and we're not going to have any units there. And that's it. And see, we have the column here. So what we're going to do, the minimum slope would be from this top of this error bar, connecting a straight line through the bottom of this last points error bar. So we're going to want to add our, oops, made a mistake. So we need to come in here now that we have our min slope, come in here and actually type in some values. So our uncertainty is plus or minus 0.04. So we have a 0.413 is our data. So we're going to, for the minimum slope, we want to be up here at this upper end of the error bar. So in this case it'd be 0.453. And And for this one, we're going to subtract 0.04, so it'll be 1.146. It's got it. Now we actually want to see this on the graph. Oh, it looks like there's an error bar. So go over here to min slope and we'll right click on it, column options, min slope. Turn off the error bar calculations, we don't need that. There we go. So we can see the right there and there. And we want to do the same thing with a max slope, so we're going to come in here, data, new manual column, max slope, call it max for short, no units. I guess we can, no error bars now, so that's fine. Done. And here we're going to do the opposite. For the max slope, we want to start here at the bottom, this point, so it would be our 0.413 subtracting a 0.04, so was it 373? See if I can add. And here, this one we're going to be up at this top end, so we're going to add 0.04, so 1 point. Oops. Yeah, 226. Let's come over here and let's right click on the graph itself and do graph options and check this max slope box also, so we can display that. And do we want to rescale this? There we go. So we have our little orange triangles here now. So we can now do some linear fits here, and we have, well, let's do best fit, a linear fit for all three. There they are. Here are your data for your 3 lines. And you don't get to claim it's a linear relationship unless the lines pass through all the error bars. In this case, it's fine. It looks good. So we would have we have our average slope. There's max. There's min. So let's put these down here. It's max, min, and then the average is put in the middle. And so you could get the slope here, and you could find how far apart they are and get a plus or minus there. And you can use these values, plus or minus, maximum and minimum, to calculate your maximum and minimum values for G, for gravity, and see indeed where, if the true value of gravity lies somewhere in between there. And that's it. That's you can cut and paste this. So if I just click on this graph to, let's see, I can copy or Control C, and you can cut and paste that into a word processing document. Okay, that's it. That's how you use Logger Pro to analyze your data. We'll see you. Bye-bye.